so much time with your busy schedule with your education. I mean, I'm just trying to help you. What up, Algebra 2 students? Let's get this party started. I'm going to start off with a video. I know that for those of you online, I hope your mom's all right. I know that for those of you online, this will be a very laggy video for you to watch. So I'm spamming you the chat right now. I'm spamming you the link to the video in the chat. I'm going to play it for the people in class. Yeah, let's just do this.
This, in a contextually relevant sense, is it. We need maximum expenditure of bodily fuels. Biosynthesis of glycogen, polysaccharide reserve, tissue in the established confines, fully maturated male, Latin and Greek derivation of a purely expository nature. Aggregated whole. This is our domicile. Whose domicile? Our domicile!
Alright, I love that video. It's a commercial for Berkeley, for the Berkeley football team. And it was playing at the game when I was playing in the band over there. And I was like, oh, that's such a good video. Because...
You played in the band over there?
Oh, yeah.
Oh,
Actually, we used to
cool.
play...
Play.
Huh? Oh, I'm a trombonist. Didn't I take out my trombone and play?
But you did it
Oh,
for
did it for chemistry. I see.
Yeah.
Okay. All right. Yeah, I used to play music. In fact, somebody was asking me if I knew Sublime. You guys heard of Sublime?
Yeah.
Yeah, and I was like, oh yeah, actually I played music with Sublime. Well, back when they were Bradley Knoll.
Oh.
Back when it was like Cool Sublime. I don't know what it is now. Because they were like, do you know Romeo Sublime? I was like, what? What's that? But there's a trombone solo in the one Wrong Way. And he goes, yeah. No, that was me.
Oh.
But when we were at the big melee, my band was playing on the stage, and they needed a trombonist to do the solo, so I get to play music with them. No, I didn't record that. That guy's really cool. Yeah, but my favorite part about that video, what I like about that video is it's kind of like a football video, and they're like, yeah, we'll beat you in football, and we're smarter than you. So that's my favorite part about it. But anyway, there's a last part where it says, whose domicile? Our domicile. So today, today one of the first topics we're going to cover is domains. Here's my plan. We got functions 8, 9, 10, 11, and polynomials 1, 2, and 3, and whatever. Got it? Coming up. I'm going to cover functions 8 today. It's going to be quick. I think it's easy.
Oh, can we go over
I'm going to
some
skip
points?
functions 9, 10, and 11. I'm just going to say I'm skipping them. Sorry. I'll try to teach it to you if I need to. I'm going to go over polynomials 1 today and hopefully get to polynomial 2 today. Got it? That's a lot of material. And I think that it will be good. Stop me if you need help. Yes, I want to go over 7.3. Did you watch yesterday's video?
No.
I did go over 7.3 yesterday in a special class, and I uploaded the video onto YouTube, and I posted it in the class already.
Okay, maybe I should check that out.
So it's a very special class because I spent all Monday doing like a review, and I didn't cover 7.3, which is what I needed to do.
Oh.
So then I was like, well, since I gave you guys a freebie tutoring day, I asked you guys to come in extra. Not required you, but I just said, hey, I'm going to hold a special class tomorrow morning.
Oh, so that was...
And that was on 7.3.
Okay.
Yeah. So and that will cover it for you. I think that when you see it, you'll be like, oh,
Yeah.
that's how to do it. This inequalities thing is really easy. All right. In the very end of that video, they said, whose domicile? Our domicile. And I plan on going to the UH game and using that cheer because, actually, the UH game that's coming up on Sunday at the volleyball game because it's saying, whose house is this? This is our house. Do you guys ever hear that cheer? Like, protect this house. Protect.
I feel like
You guys don't go to football
I feel like
games.
That sounds familiar.
Okay.
I feel like that sounds familiar, but
Alright.
I can't remember where.
Well, no, I mean, most schools see their stadium as their house and just be like, this is our house. You coming into our house and disrespecting our house, you're going down. That kind of stuff. You know what I mean? I get all crazy when it comes to like sporting events and like I paint my face and anyway. But then I became a nerd and you know, am a lot less crazy most of the time. So domains. there's really two that I want you to take a look at. And behavior. Oh, I didn't print up anything. All right, anyway. Domains. There's two functions that I want you to take a look at. And one of them is a crappy pen. Can you see that, Lucas? All right. I'm going to do this one a little bit slow. How's about I'll make a little table, and I'll say f of x is equal to the square root of x. I might have more pens. Let me go look for them real quick. F of x is equal to the square root of x. Here's what I want you to do. Put in a few values for x. And solve out y. Figure out what y is equal to. I don't have any good pens. Alright. Maybe this orange might show it. So, if x is equal to 0, what is y equal to? What's the square root of 0? 0. If x is equal to 1, what is y equal to? 1. If x is equal to 2, what is y equal to? It's 1.41. Yes, I know this information off the top of my head. If x equals 4, what is y equal to? 2. Okay. And if x is equal to 9, y is equal to 3. And so on and so forth.
Those could be positive or negative, right? Because you can have
These can be positive or negative?
Yeah, because you can have a positive square root and negative.
No. Actually, you can't. If x equals negative 4, what is y equal to? Y is equal to what the heck are you talking about? Right? Because what is the square root of negative 4? And the answer is what times itself gives you negative 4?
Yeah.
There is no number.
I got 3 hours
Of which I know of none.
Yeah.
So negative 4 is
Okay.
not allowed.
Yeah.
In fact, actually, that's kind of the point here.
No,
It's not allowed in my domicile.
Yeah.
This is my domain. You cannot have negative stuff coming in my domain.
So
That's what kind of domain is. It's what you're allowing to come into the function. Whose domicile? It's my domicile. That domicile don't allow negative numbers.
What about the y? The y values be negative?
Okay? The y value is this thing. So we have two words. One is called domain,
Yeah.
and that's the x values that you're allowing to come in. Another word that I might introduce to you, I can introduce it to you, is called the range. And it's basically what domain is to x, range is to y. It's what y values are allowed to come out of the function. Now in this case, will I ever take the square root of a number and get a negative answer?
Yeah.
Will I ever take the square root of a number and have that equal, that's equal to negative 7?
Yeah, negative times
Like,
negative.
X or
is
Y?
positive, so-
No, for the y, will I ever get a negative number in the y over here?
Possibly.
Yes.
We've established that you can never put a negative number, no negatives.
You can't put it in
But
the
the
x,
y,
but
right?
you can put it
Can
in
you put it in the y?
Yeah.
Yeah. Yeah, because you can get
No negatives.
oh, really?
No negatives in the y. Oh, I mean, think about it. Like,
Well, but if x equals
okay, all right, here's what I'm saying. Tell me any x, anything at all.
9.
9.
Yeah.
So
But the square root of 9.
if I take 9, if I say I plug in 9 over here, and y would have, or x would have to be 81, and y would probably be positive 9. 9 times 9 is positive 81.
Yeah, and negative 9 times negative 9
Is positive 81.
So you,
So only positive numbers can come in,
yeah.
which kind of implies that only positive numbers are going to come out. Does that make sense?
Yeah.
Vertical line test. You can't have 2 points existing on the thing.
Yes, that's also, well, no. That's not necessarily relevant here. But anyway, here, let me try to graph this for you, if that's all right. If I graph x equals 0, it will be at 0, 0. Got it? I'm just going to take all these points. At 1, this goes up to 1. At 2, 3, 4, this goes up to 2. At 2, this goes up to about here. Kind of like around here. We cool? If I were to graph this and I could keep this game going, this guy would kind of go up like this. Are we cool with that?
Yeah.
Will the y value ever dip down to the negative side? Will it ever go like that?
Oh no.
Oh, of course, right? I mean, if you look at the pattern, it will go up higher and higher and higher
Okay.
as it goes up further and further and further, so it will never dip down to the negative side.
All right.
Does that make sense? So what is my domain in this case with the square root of x?
All numbers greater than or equal to 0.
So
All
domain,
real numbers greater than or equal to 0.
in plain English, is all positive numbers. Or, yeah, all positive numbers. That's what is allowed to put in. There's a domain issue here. Does that make sense? If I were to put this in math terms, this is in words. I would say, see this stuff inside the square root? It has to be positive. A way to write that is the stuff in the square root, which is just x in this case, has to be greater than or equal to 0. Does that make sense?
Yeah.
And in interval notation, that would be 0 parentheses infinity. Oh, wait. It would be including 0 as well, so I changed it to a bracket instead of a parentheses. Are we coolios with that? What does Lucas say? Yeah. Lucas is absolutely right. We cool? We good with this? Yeah?
Yeah.
Okay, all right, good. I want you to keep this in mind because this is one special case. Domains, really, there's only 2 special cases that you need to keep in mind. This is one of them. Not that hard, okay? The second special case is, I'll draw it over here. Lucas, tell me if you need me to, draw it or erase this thing or whatever. I'm going to draw my axis over here. Actually, I'm going to put it a little bit more like this. And here's what I'm going to do. I'm going to make, this time f of x is going to equal to 1 over x. Here's another situation, another scenario where you're going to have a domain issue, so I want you guys to be able to see it. Here's x, here's y. If x is 1, what is y equal to? If I plug a 1 into here, 1 divided by 1 is?
0. No.
1 divided by 1 is 1. If I plug a 2 in here, 1 divided by 2 is
0.5.
1/2, or 0.5. If I plug a 3 in here,
1/3.
this is 1/3, or 0.3333, whatever. Okay? Are we cool with that?
Yeah.
And our negative is allowed. If I plug in a negative 2 over here, what is that?
It's negative.
Negative 1/2. Because you just have 1 divided by negative 2. Negative 1/2.
Yeah.
So negatives are allowed. Okay. What about negative 1? What is that going to be?
Negative 1.
Negative 1. All right. Let me start plotting parts of this graph. At 1, it's here. At 2, it's halfway. At 3, it's a third of the way. Okay. At negative 1, it's down by negative 1. At 2, it's negative 1/2. All right. So as I go further and further out, this graph is going to go further and further down. Are we cool with that? And then as I go further and further back, this graph is going to kind of go that way. Like that. Can you guys see that? Can everyone see that?
Yeah.
All right. What if I plug in my table? What if I plug in 0.5? what's going to come out? If x 0.5 goes in, what comes out?
Oh no, just 2. Sorry.
2. 2 comes out. Because 0.5 is the same as 1/2. And you have 1 divided by 1/2.
Same as multiplying by others.
This is the same as multiplying by the flip over of this guy, which is basically 2 over 1, so it's just 2. We cool with that? Or if I plug in 1/3, what's going to come out? 3. Yeah. All right. What if I plug in 1 over 100? 100 is going to come out. Okay. So as I get closer and closer to here, like at 1/2, this thing goes up to 2. And at 1/3, this thing goes up to here. And at 1/100th, which is really close, this thing goes up way up to 100, way up there. Are we cool with that? What if I plug in 0?
You can't do 1 divided by 0.
0.
So,
Why can't I do 1 divided by 0?
yeah, you can't.
Why not?
0 is 0.
You're just not
It's
doing
not-
I guess maybe, I mean, see, people are always kind of freaked out about that. And I always want, like,
It comes out as an error on a calculator.
okay, because it comes out on there the calculator. All right. How's about this? I have 1 sheet of paper, okay? I'm going to make the sheet of paper smaller. So now I ask you, how many half sheets of paper can I fit to make 1 sheet of paper?
2.
2, okay. So half a sheet of paper requires 2 halves to make the whatever, right? All right, so what if I took this half and I ripped it in half again? How many of these quarter sheets of paper does it take to make
4.
4? All right, but I'm not at 0 yet. Well, oops. I screwed up ripping that one, but how many does it take of these?
8.
8, maybe 10, I don't know. Depending on how big this thing. I'm not at 0, this isn't 0.
Yeah, so you can never get it
So-
to 0, no matter how small you.
No, you can get it to 0. I'll show you. But I'm not at 0, I'm really close.
Yeah.
Do you see that? It's good against my black shirt. How many of these fit in a piece of paper?
Probably 100.
100? Okay. But this isn't 0. So I got 1 fiber of that piece of paper of this thing over here. How many of these? Do you see that right there?
No.
No, of course you don't. But how many of those fit into that thing?
3.
Right. All right. So then, like, I take out my electron microscope and I take off 1 molecule of that thing. It's not 0 yet. How many of those fit in there?
Probably millions.
Billions, maybe. All right. So then let's go beyond this, and we'll just say let's get 1 electron off of that thing. Do you see it? Here's the electron. It's right on my thumb. How many of those fit? Quadrillions or whatever. How many zeros fit? Because we're close to 0. We're at a single electron of a molecule that's of a piece of paper.
0's not existent, so.
But I mean, like, all we did was we got smaller and smaller and smaller, and then what happened to the number?
It got bigger.
It got bigger and bigger and bigger. If you got so small that you decreased to nothing, how many nothings can you fit in there?
Infinity.
Infinite amounts. So much that you can't even count them.
Nice.
So what I'm saying here is this thing goes up and it explodes up as you get closer and closer to 0. But exactly at 0, you can't get there. Because that number goes up so quickly that it goes to infinity. Does that make sense?
Yeah.
See, I'm excited about this because this is actually new math. This is math you probably haven't seen yet. The same goes over here. As this thing goes down, it goes down to infinity. Okay? We call this vertical line right here, and it's you don't see a vertical line, but do you see it now?
Yeah.
Yeah.
We call this a vertical asymptote. You said asymptote? Yeah. I always thought it was funny too. An asymptote. It's a line that gets closer and closer and closer to, but it never ever touches. As a punishment for my 10-year-old one time, I told him, I said, all right, he did something really bad, like lie or something like that. I told him, here's what you got to do. You stand over here, and all you got to do to get out of timeout is walk out of the door. But here's what you're going to do. You're going to stand over here, and there's the door over there, and I want you to go halfway. I say it goes halfway. And then I say, okay, now go halfway again. He goes halfway again. And he goes, now go halfway again. And he goes halfway again. And halfway and halfway, halfway. And you keep doing that until you get out of the door. Then you can come out of timeout.
That's terrible.
Yeah, I know. It was horrible. He was there for an hour.
It's like mathematician for
Yeah, I know.
like, I'm close enough for practical reasons.
So he's like, I can't get out of this door. It's approaching. It's getting closer and closer and closer. It will never get out of the door. I mean, if you're talking about I'm one molecule away. Well, now you got to go half a molecule away. Now you got to go a quarter of the molecule. Let's keep going. Let's play this game, dude. That's what an asymptote is. It's kind of this idea of something gets closer to, and as this thing gets closer, this thing will explode and it never touches. There is a vertical asymptote. Okay?
So is this like helping to prove infinity, or
This is kind of giving you guys the basics of infinity. And the concept of infinity is actually pretty much calculus. So this is the beginnings of it, but this isn't that bad. All I really want you to know is there is a domain issue if you have a fraction. The thing in the bottom of the fraction cannot be equal to 0. Make sense? This thing, x, cannot equal to 0. That's all I really want you to understand.
So how can you tell what the domain is just by looking at the function? Like I know that might sound.
No, I'll show you. It's really easy. Yes, I hate saying it's really easy to people, but this one is actually not so bad.
Without doing all the guess and check, plugging in things into a table.
Yeah.
Is there a way to do
By the
that?
way, just before I erase this, do you guys see a horizontal asymptote?
Yes.
Where's that at?
That's right at the.
It's right here.
Yeah.
As this thing goes further and further out, does it ever get down to 0?
No.
No. But it gets really, really darn close to 0. Does that make sense?
Yeah.
And that's basically saying, if this number gets really, really big, this number is going to get really, really small. But I can't ever make that number exactly 0, because that would have to be infinitely big. Does that make sense? So it's kind of a horizontal asymptote that kind of curves off to that. And this is actually, this idea that we're talking about with asymptotes and end behaviors of graphs, that's actually what Polynomials Chapter 2 is. So I told you that it wouldn't be that bad. Anyway, that's the two functions I want you to understand. And let's, you know what? See, the disappointing thing is they don't even do what I want them to show you in this stuff. I'll tell you what, I'm going to show you how to apply these two concepts, and I'm deviating from the book here a little bit. Because I feel like we're going to go through kind of a natural, like let's be organic with our learning and actually, change a little bit based off of what of what I'm teaching you. So, here's how to apply it to a problem. And maybe I think that this might be like advanced topics. I don't think it's that advanced, but I think this would be like what we would cover in Polynomial 5 or something, Chapter 5. If I have something like x squared plus 3x plus 2. What is that a graph of?
Parabola.
A parabola. Are there any domain issues?
No.
Do you see a square root?
Yeah. Nope.
Nope, I see a square, not a square root.
Oh.
Do you see a fraction?
Nope.
No domain issues. Check. So what is the domain? The domain
All real numbers.
is all real numbers, and we usually write that with an R with a double line over there.
And is it still all real numbers if say b is a fraction?
All right. Well, let's try this one. If what is the fraction?
If the b value.
Oh yeah, sure. If I have a 1/3
Yeah.
there, yeah, that's
Right.
fine. All right.
Just making sure.
Well, what if I had this? What if I said this? 1 over x plus 3. Is there potentially a domain issue here?
No, because it's never gonna be. You're never gonna have 0 because
Sure, you'll have 0.
Oh, yeah. If you put
If you
negative.
put in x equals -3, that's a problem. So what you do is you say, well, this thing in the denominator cannot equal to 0. That's one of my rules. That's the second rule that he taught me. So I say x plus 3 cannot equal to 0.
Oh, okay.
Or x cannot equal to -3. Just take the -3 over to that side. That's how you figure out the domain. So what is the domain issue? The domain is, I don't know, how would we write that? We would say, I would just actually say this. X cannot equal to 3. But x is allowed to be anything else. It can be anything it wants to be, except -3.
Okay.
Does that make sense to you?
Yeah.
So like this is just
Maybe to do it in interval notation, you can do it like this. You could say anywhere between -∞, comma 3, or comma -3. So that takes care of the left side.
okay.
And -3 to infinity. So that takes care of the right-hand side. So basically, it's like a number line that says everything except that sucker right there. And that guy's standing at -3.
So if you're to graph it, would it just like jump over 3?
Yeah, it's just kind of go like this, and I have a hole right there, and then keep going. Cool? So this is the graph notation. Here's the interval notation, and here's the set notation. I think I might have gotten those backwards. I'm not sure. There's a whole bunch of names. I'm never really concerned about the names as much as I am concerned about like the understanding of it. Do you understand it? Good. We're moving on.
Wait, but why does the domain say -∞, -3 when -3 can't actually be?
Because I have a parenthesis here, say, which is saying from -∞ all the way up to -3, but don't include -3.
Oh, okay.
And then I say from -3, not including -3, and then everything on the right-hand side of it.
But then wouldn't the parentheses by the infinity be a bracket to show?
This
that
one over here?
Well, to show that it includes.
In my discussion yesterday,
infinity.
I say that you can never have a bracket next to an infinity. It's always going to be a parentheses next to infinity. The reason being is because infinity is not a number.
Oh yeah.
And when you have the bracket, it's equal to. And when I'm thinking equal to, I'm thinking equal to a number.
Oh yeah. But you can never have something equal to.
Nuh-uh.
It just goes on.
Nuh-uh to infinity. Nuh-uh to infinity plus 1. It keeps going.
Yeah.
Right? Come on, you played that game when you were a kid.
Yeah.
Do you have a brother or sister?
I have a dog.
Well, your dog probably didn't play that
Oh,
game.
yeah.
All right. Does everyone understand this?
Yeah, that makes sense.
What about this? What about this? How's about this one? The square root of x plus 3. What is x? What x values am I not allowing in my domicile?
Negative. Well,
No, I could
well,
use -2.
It can't be.
-2 is allowed, right?
Yeah.
Because -2 plus 3 is +1. I can take the square root of +1. We're good.
It can't be less than -3.
Ah, okay. So you're
Less
saying
than -3.
on a number line, my answer is here's 0, here's 3, here's -3. You're saying not including -3 and everything above,
Yeah.
No, including -3, because then it could be 0.
including -3.
Oh.
Because zeros are allowed inside the square root. They're not allowed inside the fraction. That's true.
Oh.
But they're allowed in the square root. Does that make sense?
Yeah.
So, yes, you're absolutely right. And if I wanted to do this in interval notation, or this is graph notation, if I wanted to do it in interval notation, I would say x is bigger than -3. I would also say in set notation, I would say between -3 bracket, comma, infinity, parentheses. That's it. And the mathematical way you would go about this is you would look at this and say, wait a second, that's the first thing he showed me. There's a problem when I see square roots. Everything inside here cannot be negative. So what you write down is you write x plus 3 has to be greater than or equal to 0, and then you solve that. x has to be greater than or equal to -3, which is what I have here. Oops, I forgot the equal sign. Alright. Are we cool?
Yeah.
That's it. That's the 2 rules. I feel like the rest of this chapter is dumb. In the way they put it. I don't like the way they put it. I'll show you a few things that they said. But to me, the rest of the chapter is kind of dumb. Yeah. Let me do one more of my style problems first, and then I'll do some other stuff. Cool. Let's do one more of mine. How's about 1 over x squared plus 3x minus 4. Yeah, x squared plus 3x minus 4. Okay? Yes, square root of 0 is allowed. Lucas is asking, wait, so square root of 0 is allowed? Yeah, you can take the square root of 0. It's 0. What times itself gives you 0? 0. All right. Anyway, is there a domain issue?
No, because if you plug in 0 for x, you will get -1 over -4.
There is a domain issue. Why is there a domain issue? Because I see a fraction. Technically, it's when I see a fraction with an x inside of it. If I have like a 1/3, that's not a domain issue. You know what I mean? If the x is in the denominator, then you have a domain issue. Got it? But I see a fraction. And I have to say that stuff in the denominator cannot equal to 0. Okay? X squared
that
plus
whole thing
3x
can't
minus 4 cannot equal to 0. Right. Because if the whole thing is equal to 0, that's a problem. You've got 1 divided by 0.
Alright. Oh, I was thinking that x by itself can't equal.
No, x can.
Yeah.
X is totally allowed
Yeah,
to be
x-
0.
yeah,
If you
x
plug a
can't
0 here, 0 here, you get -4.
Yeah, that's
1 over -4 is totally a number. No
Okay.
problems there. But this cannot equal to 0.
Yeah, the whole thing.
Yes.
By itself can't equal
Do you know how to solve that?
0. You just factor it out.
You could quadratic equation that sucker, if you wanted to, or you could factor it. X plus and minus. Do you guys know the numbers? 1 goes where? Right where? Yeah, -1, +4. Cannot equal to 0. And I know that you guys aren't used to seeing it like this. You know what you guys are used to seeing? But you do the same thing with the not equals. You just say, oh, okay, well, that's saying that x plus 4 cannot equal to 0, or x minus 1 cannot equal to 0. Right? And then you say x cannot equal to -4, and x cannot equal to +1. Because if x equals to -4, this would become 1 over 16 minus 12 minus 4. What's 16 minus 12 minus 4?
0.
0. So this would be 1 over 0. That's a problem. You guys see what's going on here?
Yeah.
X can also not be equal to 1, because if x were equal to 1, I would have 1 over 1 squared is 1 plus 3 minus 4. What is 1 plus 3 minus 4? Also 0. There's a problem. So then you would say, oh, there's a domain issue, and here's the domain issue. It's right here. In interval notation, that's what I would write down. In set notation, that's a pain in the butt. I would have to use a whole bunch of unions to
So, for the homework,
express
do
that.
we have to do it in...
Actually, this isn't on your homework. I'll show you what's on your homework, which I actually...
But do we have to put it in that weird
Oh,
parentheses notation? Or can we just
on
do
your
it?
homework, you'll have to put it in that parentheses
Oh.
notation. And I teach you how to do it in 7.3. If you watched the video from yesterday, I basically spent 20 minutes teaching you how to do it.
Okay.
It's actually really, I don't know, I felt like it was really straightforward for 7.3. The reason being is because I don't know how to tell you, I don't know how to type this into the calculator or into the computer. Actually, I know exactly how to type this into the computer, but I don't know how to tell you to type this into the computer. And I don't know how to tell the computer to grade this. if they use these exact symbols at this time, you know.
Yeah. Okay.
So anyway, here's the way the book wants to teach you domains. We're done with domains. I feel like we're done with domains. I feel like I've done a good job with teaching you, but here's the way the book wants to show you. They say something like, h of t is equal to negative 16t squared plus 40t plus 24. Okay. They want to figure out what is the domain of this thing. Well, here, let me show you. What we're dealing with is what is this graph? What?
Parabola.
It's a parabola. Is it a happy parabola, sad parabola?
Sad.
It's a sad parabola. In fact, you're so used to seeing this parabola with the negative 16 and the 40 and all of that kind of stuff.
The equation for gravity.
Right, this is gravity, or this is actually half of gravity. This is the velocity that he shoots off at, and this is actually the y-intercept, right? 24. So apparently, this is what the parabola looks like. Got it? And this is the time axis, and this is the height axis. We cool with that? What is the physical domain of this, though? What time values are allowed in here? Let's pretend that this was a bow and arrow. All right, I'll tell you the story. Fine. I take a bow and arrow. I shoot it from a tree. So I'm standing inside of a tree. There's a tree. I'm standing here. I shoot my bow and arrow. Goes down. Got it? What time values am I allowed to measure for when the thing is in the air? That's my question for you.
Between the y-intercept or vertical line and the x-intercept on the right side.
Ah, good. So you're saying between here
Yeah, 0
and
yeah.
here.
Between the two intercepts, the line.
Yes, the domain over here, even though technically this is a part of the parabola, it doesn't really make sense over
You
here
can't have negative time.
because there's no negative time. And also, we're going to kind of erase this part over here because, if the thing were a ball and it bounces, then yeah, sure, maybe you can have a domain outside there. We're talking about an arrow, so it just gets stuck in the ground and it stops. So there's no time that it's in the air after this time. Does that make sense? So my domain is between there and there. Now, how do I figure out what that point is? This is no longer talking about domains. This is talking about like what you guys learned.
Factor it out.
You set it equal to 0 because that's when height equals 0. Then you solve for t. So you set this equal to 0. How do I solve a problem where I have something t squared plus 40t plus 24 equals 0?
Quadratic.
Use the quadratic equation and you get your t, and that tells you the time at which it was 0. You're going to get two times. One of them is positive, one is negative. You throw out that negative time. How come?
Because you can't have negative time.
Because that's not within your domain. Because it ain't in your domicile. Right. And so you just throw it away. You're just like, this is an extra answer that I don't need. So you have one time over here. And then what is your domain? Well, it's between 0 and whatever that number is. Say it's like 3 or something like that. I don't know. We cool with that? You figure out what that number is after you plug it into the quadratic equation. I think they gave you something funky like this. What if this were my graph? All right, so that's one problem. I think the other problem is like, what if this was my graph? Looks something like this. Say that I take measurements of the temperature every day at the exact same time. So like let's say like 4 o'clock in the afternoon, here's day 0, here's day 1, day 2, day 3, day 4, day 5. What is my domain?
0 to 5.
Anything negative at all? No, so just
I'll tell you what my domain is. What numbers are allowed to come into this?
0 to 5, right?
Or what numbers are you allowed to ask me about?
1,
Numbers.
0 to 5.
So, yeah.
1, 0, 5. I agree with you. That's 3 of the numbers.
0, 1, 2, 3, 4, 5.
0, 1, 2, 3, 4, 5. Are you allowed to ask me about 1.5?
No.
No, because I didn't take a temperature measurement of that. So that's not within my domain. What else is in my domain?
3.
3, exactly 3, but not 3.5, not 3.1, not 3.0001. That's all not within my domain. It's exactly at 3. That's my domain. So if you want to write down what is your domain here, I would say something like x equals 0, 1, 2, 3, 4, 5. That's it.
Or X is. Or some weird thing
Some
like
one way you would
0
write that is actually
plus-
use this, and this is something super advanced that you guys wouldn't have ever seen. You know how all real numbers is the R?
Yeah.
Z with the double line, that stands for integers. These are all the integers in between here and here. You know, and let's pretend that this graph goes on forever, so I only plotted out the first 5, so you go 0, 1, 2, 3, 4, 5, to, you know, forever. Sure. What about this one? Is that in my domain?
Nope.
Sure, you could ask me about yesterday's temperature, right? Or the day before that. I'm fine with that. Assuming that I, you know, took
Oh, yeah.
data back then. But yeah, that's totally allowed. You can ask me about, like, the day before, whatever. I guess it depends on where you're setting your 0 equal to. Is 0 today, or is 0 like when you started? If 0 is when you started, then you're right. This is not in my domain because I don't have any data. You know, before I started taking data. Does that make sense? That, my friends, is the culmination of domain. Yeah, Ethan, you can't actually say 0 to 5. Because 0 to 5 would be assuming you're allowed to take all of the numbers in between. That's not true. You're only allowed to take 0, 1, 2, 3, 4, 5. All right, good. I'll tell you what, let's take, I don't know if I want to look at your homework. Let's move on. Okay. Here we go. Can you grab these? 2 for you guys.
And just pass them out.
Yeah, here. They're packets. Here. Sorry, I'll grab one. Thanks. All right, I'm looking at polynomials 1. I'm skipping functions 9, 10, 11, whatever. It's not that I feel like it's important. That's not important. The reason why I'm skipping functions 9, 10, 11, and whatever is because I feel like polynomials is more important, and I feel like we're actually behind. I looked at where we were at last year, and we were on functions 3 at this time. Or not functions 3, we were on polynomial 3, like that was due this week, last year. So I kind of need to just say, well, I think domains is a really important topic to cover, so I'm going to cover that. But after that, composition of functions, ranges, yes, they're important, but not as important as polynomials. Cool? So I'm going to do polynomials 1. And what time do I got to finish? 2:15?
210.
2:10? All right. I'm going to do polynomials 1, and I feel like polynomials 1, I don't even think I gave you homework on it. It's one of those things where it's almost like, actually, I think I might have given you homework, and the homework is really, really easy. It's one of those things where I really want you to understand the concept. It's kind of like that section where, like, chapter functions 5 was just taking notes. You know what I mean? I want you to understand the material, but I don't necessarily think that there's any relevant homework that's coming out of it. Cool? Let's play this game. And for those of you online, I apologize, you can't really play the game with us. Here's what I want you guys to do. On the first page over here, I listed out a bunch of functions. I want you to group up. You can make a group of 3 if you want. We'll have 2 groups, and then a pair, and then a group of 3. I want you to kind of group these guys together. Like, these functions are part of families. I'll show you what the first page of this thing looked like, which I always thought was the weirdest thing. All right. So the first page that I didn't copy for you is a bunch of dogs. Yes, this is actually from your math worksheet. It says, group all of the pit bulls together and the non-pit bulls together. It's basically saying functions come in kind of like families or species, or I don't know, what is that classification called? I don't know biology very well. Is this like kingdoms or pit bull versus non-pit bull? Is that what, like genus? No. What is it? Oh, breed. Okay, yeah. All right, it's a breed. So if you group them by breed. So functions come in breeds. How's that? And I would like for you to figure out what those breeds are by just looking at a bunch of functions and making up your own grouping together. Say, I could see how these guys are related. Cool? I'll give you guys like 5 minutes to do it. Have I ever owned a dog before? I've had a golden retriever, but that was when I was a baby. Oh, I had 2 Basenjis. I love those guys. We're on page 1 of Polynomials 1, if you guys want to take a look at that. I kind of want you guys to try it. Try it at home. Let me know what you guys think. It's almost embarrassing how bad at biology I am.
Is the one that goes
Because it is chemistry.
or this one right here?
Well, chemistry is
Yeah.
as far away from math and physics that I can get. If you want me to teach biology, you're going to
I'm
have
not really sure what it is. Let's
not so very
put,
So maybe like, say this is group 1 and group 1 or something.
let's put all the stuff
A
with
and A.
X's.
Yeah, call them A, B, and C.
All the stuff with all X's that have
These
X's.
3 groups together, like the
Oh yeah, those
G.
Yeah, so you can put like asterisk. This is a part of the asterisk group, and here's a part of the stars, and here's a part of the happy faces. I wonder if Desmos.
oh no, that's
Because they're
sorry.
not, they're not.
Not seeing
Maybe those in the first one.
Oh, Lucas, yes, I love scaling the universe.
And this is
sorry.
Sorry, what?
No, not that.
Oh.
Sorry, there's one at the fourth one. So this top right one and that bottom center one.
Well, I guess they would be for.
Would also be
you guys
If you look at the Y's, then this one counts.
Grapher.
but it doesn't have X.
I was just
But
about
I'm not sure if that matters.
I think so, yeah.
Because these are polynomials.
Oh. Okay.
Did you put,
Oh yeah.
this one, this one, because they can have this was.
I think that 2x plus 2 is also similar. It's just the similar functions.
You guys done?
Yeah.
All right, cool.
Yeah. I'm
Even the one.
great.
See you too, Mr. Jonathan.
Uh,
I'll
Did-
leave you mine.
yeah, sure,
You're gonna go eat something.
sure.
Quick.
Wait, Monster, is that a Nerf gun? There's a Nerf gun in there.
Yeah, it's got like the satchel with pockets in it.
It's awesome. Is that yours?
Yes.
Coolest teacher ever.
Obviously, the teacher would have. I mean, a physics teacher would have Nerf guns. Okay. So, how did you guys come up with your groupings?
We just identified them, whether they're fractions.
Use them off what they look like.
All right,
the stuff
so-
with
so let me
X's
know.
and Y's mixed and all the stuff with just X's and all the stuff.
All right. So, if you had X's and Y's in there at the same time, is that its own group?
Yeah.
Okay.
We got to.
I agree with you. I'll show you what it actually looks like. The first graph actually looks like this. It's called a contour plot. It kind of looks to me like a, like, you know, when you're looking at a map, and you're looking down at a map and it has all the circles for the different altitudes. That's exactly what it looks like. It's actually a contour plot that looks like this. You're actually graphing a circle,
Oh yeah, that's the simple
believe it or not.
formula.
That breaks all
thing.
the rules.
Couldn't recognize that.
Yeah. It does. It totally breaks all the rules. It's not a function, which is
Wow.
might be why it belongs in its own breed.
Oh, okay.
Cool. So I would say the top two on the left are its own classification, and then what about the top left or the top right hand side? What about that one? Is that its own group?
Yeah.
No.
No, we have
What else
like
goes in that
three
group?
different others.
Which other ones go in that group?
The first one on the third row, and then the first and second on the last row.
Ah, I see. How come?
They look alike, and they had fractions.
Actually, I think this one with the X on top is separate from these two.
Okay. I know what you're thinking. You're thinking because of the fractions, right? Those have fractions. All of those have fractions in them. Anytime you have a fraction, there's a problem. Here's the thing. The one on the top left has a domain issue.
But the one on the
Right.
bottom.
The one on the bottom, these ones over here, they don't have domain issues. They're just fractions in front of the numbers. I mean, it's like instead of putting 2 fifths in front of the x squared, I could technically put 0.4 in front of the x squared, and then you guys would be like, hey, there's no fractions there. I'd group it with other ones. So no, I think that this guy's in the class all of its own. And there's a domain issue. And if you look at the graph, I'll tell you what, let's take a look at the graph.
Wait, but for the ones on the third and fourth row, they have X's in it, but the one at the top right has X's in
Yes, they all have x's in it.
it. So what differs?
All right, we'll take a look at it. Okay, 2 divided by x cubed plus 3, oh wait, plus 3 divided by x squared plus 1 over x. I don't expect you to understand why the graph looks like what it does, so all right, and then maybe we'll graph the bottom left hand. Negative 21, negative 21, oh wait. Negative 21 x to the 5th power minus x to the 4th power divided by 3 plus x over 4 minus x squared
Oh, that's like that cubic. I can't
Divided by
remember what
5.
it is, but-
All right. These two graphs look drastically different. You guys agree?
Yeah.
Yes.
All right. So I think that this one on the top right-hand side, and I know that you guys can't see. I apologize. Maybe I can share this with you. Okay. For those of you online, try to check that out. See if that works. I would say there's asymptotes. I would say that the one with the square root in it, that's in a class all of the time. Right? To be honest with you, I would say everything else is all in the same breed. Is that kind of what you guys got? Okay. Let's see. Over here we give you, in the next couple of pages, I give you a bunch of graphs, and I think that what I wanted you to do is go through and take a look and see, and try to graph them and go through all of this stuff. Do I feel like that's worth it doing? Maybe. I think what's worth doing is this. Let's take a look at page 5. Okay, this page. These all these functions right here, all these pictures right here, they belong to the same breed of functions. They belong to the same family of functions. Hey Celeste, in biology, what is a family?
It's a step above. So it's like a group of
Okay. So like a cats and dogs in the same family?
They're all part of an animal kingdom.
They're all simply
I don't know. I don't know if family is the right word to use. Oh, okay, all right. Apparently in this curriculum they call them function family groups. So all of these graphs belong to the same family. And this family that we're going to call it, we actually call this family polynomials. Okay? And Sophia, you actually looked at some of these graphs and you're like, hey, I recognize some of these things.
Yeah.
Right, like obviously you recognize this one right here, right?
Yeah. And then the other ones were like.
What is this one?
parabola,
It's a parabola.
and it's smiley.
And it's a happy parabola. And what else can I say about this parabola?
Yes, two
The
X.
vertex is on the y.
The Y.
I shifted I pulled the sucker down, right?
The Y
Good.
intercept is the vertex.
Good. So a parabola, we know this particular parabola probably looks something like ax squared plus,
C, right?
actually it's something more like this, minus c.
Yeah.
Or minus k. We did that h and k game, right?
Yeah.
Because this thing got pulled down, and I also know that a is a positive number. Cool?
The Y intercept is the same as the vertex.
What about this parabola right here? What about this one? Actually, it's not a parabola. But this function right here.
I can't remember what that's called.
Well, there's not really a name for it, but what can you tell me about
It's all even numbers.
it's all even numbers? What do you mean by that?
Because x to the
No, no,
power
no. There we go. Why do you say even numbers?
I don't know. I can't remember.
Why do you say x to the power 4?
Because it has 3 bumps, and so it's 1 more than 3 bumps.
Yes. Because,
It's got 3
The
bumps.
exponent is always one value greater than the value of the
Yeah.
bumps.
It's got 3 bumps, and here's another key: is it ends in the same direction that it ends in the same direction that it started. This thing started up into infinity. This thing ends up to infinity. When they end in the same direction, they're even powers
Okay.
of exponents. And what is that even power? We know that it's actually ax to the 4th power plus bx cubed plus cx squared plus dx plus e or something like that. I don't know what a, b, c, d, and e are. Actually, I can tell you what a is. Is a positive or negative?
Positive.
It's positive. Good. What about E? Is E positive or negative? Actually, it's
It's 0.
0.
Right?
So neither of you were right, or both of you were
It's
right. I'm not
0.
sure. It's neither of you were right.
Minor as
'Cause-
it's right.
Because
Yeah.
if you look at this thing, it's actually at 0.
Yeah, and E moves it like up and down.
Yeah, E will push the whole thing
So-
up and down.
So E is just.
But also, if you plug in x equals 0, everything gets killed except that. So there we go. Are we cool? What about this graph? What can you tell me about this? This one.
It looks like someone.
It looks like
It's kind of the same thing. They just probably changed up the numbers a little bit. Yeah. All right. What about this graph over here on the bottom?
That is an odd exponent. It's just
That's like 5, right?
X to the 5th. How come? How do you know x to the 5th?
Because it's going down.
1, 2, 3, 4 bumps.
And you can tell it's odd because it starts and ends in opposite directions.
And this guy, if I go out to infinity this way, it goes down, and this guy, if I go out to infinity this way, it goes up. So they're opposite directions. And also, usually, as I, we're Americans here, we're not Japanese. We read from left to right. As I travel on this thing from the left to the right, I'm basically going up. So that A coefficient is a positive coefficient. If the thing were going down like this, and I imagine myself on a roller coaster when I play this game, then A is a negative coefficient. Did I draw that right? 1, 2, 3, 4. Yeah, 4 bumps, x to the 5th power, that kind of stuff. I wrote this thing down in a weird way. I wrote this thing down like this. ax squared, or ax 5 plus bx 4 plus cx 3 plus dx squared plus ex plus a, b, c, d, f. I wrote the other one with just to the 4th power, so I guess I used one extra letter. Did you guys notice how I wrote that down? And what is A, B, C, and D, and E, and F? Are those variables? Oh my gosh. I barely had enough understanding of X. Now he's introducing A, B, C, D, E, and F? No, they're not variables. They're just numbers. I just don't know what those numbers are, so I'm putting in A, B, C, D, and E, and F. They're just like if I had ax squared plus bx plus c. You guys are already used to that thing. These things are called coefficients. So if I asked you, what are the coefficients, you would just tell me number, 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 number. They're the numbers. They're nothing but numbers. That's all they are. I know. You look at that. That's not a number. That's a letter.
Is f a coefficient even though it's not in front of an x?
Yes, f is also a coefficient. It is the coefficient here. I just had it from decreasing, right? So I have 5, 4, 3, 2, 1, 0. But then x to the 0 power is just 1, so I just erase that. There. Does that make you feel better? All right, good. Yes, f is a coefficient. These are all coefficients. Obviously, I would use different coefficients if I have x to the 6th power, because then I would have to go out to g or something like that. Please keep in mind that maybe I should not use f. Maybe I should use j or something like that. The only reason is because I usually just say this entire thing is equal to f of x, and usually f stands for my function. I don't want to get confused between this f and that f. This is a coefficient. This is a function. Cool? Which is actually probably why I usually use the notation f of x. Because if I just had f all by itself, I would think, oh, that's a coefficient. But if I had f parentheses x, I know, oh, that's a function. That's not a coefficient.
A function of x.
Does that make sense? Okay. And the reason why I use j is because I was like, we used f for functions. We sometimes use g and h for functions. I don't want to use I because that's imaginary numbers, so I guess I'll choose j. I just chose different numbers. Okay. This is called coefficients. The leading coefficient has always proven to be something very helpful to us. The leading coefficient is this one. What information has A always told us, regardless of whether we're dealing with a parabola, a cubic function, a fourth function, a to the fifth power function, whatever.
Whether it's being vertically stretched or vertically
Vertically
compressed,
stretched,
or whether
vertically
it's being,
compressed,
like,
flipped
flipped
upside
down,
down.
or left to right.
It's the
whatever.
same deal. It does the same thing that it did all to parabolas. Believe it or not, it does it to lines, and it also does it to every other kind of polynomial. Cool? What's the last thing that I want to show you? Okay. The degree of the polynomial. The degree of this polynomial is 5. Why not 4?
5 is the highest exponent.
5 is the highest exponent. So if I think that a part of your homework, actually I honestly think that your homework is, I don't even know if I printed it up, but it says exit pass, and I gave you a bunch of functions, and then I asked, what is the degree of the polynomial? So let's take a look at this first one. What's the degree of that? Can you see it? Where my finger is?
Yes.
3. Good. What's the degree of that? No. No. 6. Lucas got it. Why?
Well, it would be because 6 is the highest exponent.
Because it's the highest exponent. Done.
Um,
What's the degree of this?
negative.
The degree of this is 1. What is the degree of this? And I'll be honest with you, I don't know. It's not a polynomial function that I can really agree with. I honestly don't think that I've ever really seen anybody ask me, what is the degree of a circle? Okay. So my answer is, I don't know. I also ask you, what is the leading coefficient? What's the leading coefficient of this? 7. What about this? What's the leading coefficient? 5.
Oh, so
Because the leading coefficient is attached to the exponent with the highest degree. Literally, this is your homework. I told you it would be easy. I want you to understand the concept. I want you to understand the classes of functions and how we group them together and why we group them together and all of this kind of jazz. And it makes sense to me. And I think that this was important information to give you, but I don't necessarily know if this is hard. You know what I mean?
Wait, so which one is that? Is that one of the...
This is Polynomials 1. I don't even know if I made homework for
There's
it.
a quizzer.
There's a quizzer?
Yeah.
Try click on the quizzer. Let's see what it looks like. Go for it, take it. You have 5 tries. Oh, yes, it is. It's exactly that. It's state the degree of this. State the whatever. Do I have the one that has the x and the y combined? Do I have? No, I don't. I skipped it. For good reason. Okay. All right, cool. Well, that's it. That's your class. You guys want me to go on to Poly 2 or what? Or you're done?
You got this just degrees again?
No, it's
And the leading coefficient is the one that's attached to the highest exponent.
the leading coefficient is the one that's attached to the highest exponent. Yes. Poly 2. All right, fine. I'll do it on Monday. It's not. That one is going to be a little bit more. I'll tell you what it is. I'll just kind of talk about it then. And give me like 2 minutes to talk about it. You remember when I had you take notes on all the functions and I had you say, well, as x goes out to infinity, this y value will go up to infinity, or something like that. What we explore in Poly 2 is exactly that. We want to figure out. We want to say, here's a function, and say I don't really care what the middle of that function looks like. I'm gonna go like this. Here, I'll do it like this. I drew an entire function here. I just covered up the middle, and you guys can't see it. What can you tell me about this function?
It's negative.
It's possible.
It has an odd exponent.
It has an odd exponent.
It has an even exponent. Right.
It doesn't need to have an even exponent. It could actually be a line. It could be a straight line. But yes, it has an odd exponent. What about the a value?
It's even. I mean, not positive.
It's positive.
Not even.
That's what polynomials too is. What if I did this? What if I made like this?
Parabola. Or
It doesn't need to be a parabola. Hey,
things.
hey, guess what? It wasn't a parabola. It actually looked like that, which had 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. So it's x to the 15th or the 14th power. But you could have told me that it's definitely an even power, and I could tell you that the leading coefficient is a positive number, even though I didn't know what it looked like in the middle. You thought it was a parabola. I didn't draw a parabola in the first place. I drew that. You get it?
How do you
That's
find
what
the
poly
degree
three
of
is.
within negative exponent?
How do you find the degree of something with a negative exponent? I think we covered one of those. Oh yes, if the negative exponent is the biggest one, I think that's degree.
Yeah, but I put negative 4 here and it said it was the degree.
Oh,
Is there an X that doesn't have an exponent?
well, I'll have to double check the answers. I actually made that quizzer like a year ago. So I'll double check that one before I assign it. I don't even know if I assigned it. When does that one due?
Huh? Oh.
Due like next week or something?
November 10th.
November 10th.
I'll do it again.
Dang, November 10th? I gave you that much time? Whew. I didn't think polynomials was that hard. Alright, anyway, we're done with class. It's my domicile. Whose domicile is my domicile?